All right, let's put these parallel theorems and converses to work. Our 3, 1, 2 proof practice. Here is your key, your video key. Ready? I want you to think about the difference between our given postulates and the theorems that we prove. You have to pay attention carefully to what is given. Are we given parallel lines and we're proving angle relationships? Because these two will go together. Or are we given our angle relationships and we're proving our parallel lines? Because these guys are the converse. So to keep that in mind. All right. So we're given the lines are parallel for number 1, and we have to prove that the angles are congruent. So here we have those lines as parallel. I'm going to write that in there as our first part of our proof. I'm given that A and B are parallel. I'm given that angle 1 is congruent to angle 4. And my very easy statement is that somebody told me that was true. That's my given. All right, so what's my job? My job is to prove that angle 2 and angle 3 are congruent. So angle 2 and angle 3. And that's what's going to go down here at the end. I'm hoping to say something like, therefore, angle 2 is congruent to angle 3. That's where my goal about where I'm going. All right, let's see what I know. If I'm given the fact that 1 and 4 are congruent, it's interesting how that crosses outside of my parallel line system. So if you look here, I've got 1 and 2 have a relationship and 3 and 4 have a relationship because these parallel lines. Let's talk about that relationship. I know that angle 1 and angle 2 are going to be supplementary. So think about, how do I know that's true? The lines are parallel and these are consecutive interior angles. So guess what? My consecutive interior angles theorem tells me if you have parallel lines, then consecutive angles are going to be supplementary. So I've got that going on. All right, let's come over here and talk about angles 3 and 4. Same set of parallel lines, but a different set of angles. Let's talk about the idea here. I know that angles 3 and angle 4 are what? Are supplementary. And how do I know that? Because they are consecutive interior angles, and that theorem tells me if the lines are parallel, which they are, then those are going to be congruent. So good news. I've got both of these guys supplementary. Now how am I going to link what's going on here? So we need to go back up here to our given. So if angle 1 is congruent to angle 4, and angle 1 is supplementary to angle 2, my congruent supplement theorem is going to let me take the next step. And my next step is going to be, let's follow that again. 1 is congruent to 4. 1 is supplementary to 2. So guess what that means? That angles 2 and angle 4 are going to be supplementary. And I know that because of my congruent supplements theorem. It says if two angles are supplementary to the same angle, then they're congruent. If two angles are congruent, then they're supplementary to the same angle. I could say that forwards and backwards. Let's say it one more time. 1 and 4 are congruent. 1 and 2 are supplementary. So 4 and 2 must also be supplementary. All right, where am I going here? I want to prove that 2 and 3 are congruent. Well, I've got 2 and 4 supplementary. I've got 3 and 4 are supplementary. So if both of these angles are supplementary to the same angle, guess what my last step is going to be? Aha, I'm here. That means that angle 2 is congruent to angle 3. Why is that? The same story. The congruence supplements theorem tells me if two angles are each supplementary to the same angle, then those two angles are going to be congruent. So I can look at using the congruent supplements theorem both ways. All right, let's talk about solving for these. Now, I'm given my lines are parallel. So I have those triangles as a given story. So for each of these, I need to solve for x. So I have to look at what the story is. Here's my transversal. So are these angles congruent or supplementary? They're going to be congruent because they're alternating exterior angles. So 10x minus 50 is equal to 7x plus 1. I'm going to go ahead and solve for x. So I know subtract 7x from each side gives me 3x. Add 50 to each side, and I get 51, which means x has a value of, what does that work out? It goes in 1 time and then 21 17 times. So x has a value of 17. Let's check out this one. We have a symbol here. What does that mean? It's a right angle. It's 90 degrees. So if the lines are parallel, what's true about these? Hey, these are corresponding angles. And maybe we should go back and write down what we're talking about. Here's alternating exterior angles. And here we're going to be talking about corresponding angles. All right. If the lines are parallel, then I know they're equal. 90 is equal to 3x. X is equal to 30. That was an easy one. X is equal to 30 is a value of 30. We don't need the degrees there. All right. Let's check out this one. All right. What do I have here? It looks like I have alternating interior angles. And here I have my parallel lines. That was given, which means that these are going to be equal to each other. So x plus 15 is going to be equal to 2x minus 30. So we've got add 30 to each side and subtract an x from each side. So it looks like I've got an x value of 45. These two angles are going to be equal. All right, let's talk about this last one. What do I have here? It looks like I have consecutive interior angles. So consecutive interior angles, I've got this guy here and this guy here. They are supplementary. So we want to do this one a different color because it's so important that we set up our equation the right way. Because when two angles are supplementary, we set them equal to 180 degrees. Combine like terms, 4x minus 68 is equal to 180. So 4x, if I add 68 to each side, how am I doing with my math in my head? I get 248. I don't want to mess this up, so I'm going to go ahead and just verify that. 44 plus 24, boom, definitely 68. 68 added to each side is going to give me 180, 248. Let's go ahead and divide that by 4. So x has a value of 62. How did you do?